Okay, I'm recording the session now. I don't know where it's recording to. Ooh, I should probably figure that out before we start. Let me see. Yeah, settings. Recording. Oh, yeah. Let me, well, that's fine for now. Great, okay. So, I'll move this over to a different window. Great, okay. So, with the GRE, there's a couple of things that you should know about the test. For each question, you've got around a minute or so to really answer each question. That's by design. They're giving you not enough time to really put as much thought into these questions as you want. For our practice session today, we're just going to go through casually. We're going to take our time and solve these questions with the amount of time that we need. And that's fine for here. When you're actually taking the test, you're not going to get 10 minutes to work through a problem. You're only going to get a minute and a half. And the idea is that you should the better you know how to solve these kinds of problems, the better you'll be able to just immediately sort of like snap, figure out, okay, I think I know what I need to do here. And even if you aren't sure what you need to do to get the right answer, if you think you can figure some things out to eliminate some of the answers, that's going to help out a lot. I believe there is a penalty for guessing and guessing wrong, because wrong answers actually lower your score. It's not like some tests where it's like, well, I don't know what it is, so I'm just going to guess and maybe I'll get it right. And it'll only be good for me if I guess right. And it won't do anything bad for me if I guess wrong. That's not necessarily the case on the GRE, because I believe wrong answers actually detract from your score. They're worth negative points. So you want to be careful about guessing. If you think you can eliminate enough of the wrong answers to make like a 50-50 shot guess, it's much better than just saying, I don't know anything about this problem, I'm going to pick 1 out of the 5 options and hope that I get the right 1 out of 5. It's not the best way to go about it. Anyways, it's I did want to also mention that it's totally okay if you want to leave your microphones on, if you want to ask questions and things. That's totally cool. This is not a rigorous class. This is just me going over some GRE problems with you guys, and we're going to work through them together. Okay, is everyone ready to start? All right, so I'm going to go ahead and pull up the first question here. I've already gone ahead and done all these ahead of time. I don't know if we'll get through all 10. Of the 10, there's one question that gave me some issues, and I'm still not sure what's going on there, but all the other 9 are pretty solid. So let's go ahead and get through them. So I'm going to go ahead and start it up. And you can follow along on your computer as well if you want. But I'm just going to have the question off to the side right here. So here we go. First question. 20% of the trees in an orchard are apple trees, and 1/3 of the trees that are not apple trees are cherry trees. If 3/4 of the trees in the orchard are fruit trees, and the only types of fruit trees in the orchard are apple, cherry, and plum, what fraction of the trees in the orchard are plum trees? All right, so the first thing to notice here is that this question is really complicated, right? A lot of GRE questions, a lot of word questions in particular, are about, can you figure out what information is actually important in the question? Because there's a lot of words here. This is a full paragraph. It's ridiculous, right? But that's how real world problems are. And so that's the kind of problems they're going to throw it at us in the GRE. So one thing to note here, all of the answers are the dreaded nightmare word fractions, right? So the answer is going to be a fraction. So that should give you some hints as to, okay, whatever I'm doing in this problem, I should be leaving things in as fractions, because that's what my eventual my ultimate answer is going to be. So I'm just going to go ahead through some quick review here. So for fractions, let's see. Okay. Is everyone able to see my my drawings here?
Yes.
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 Okay. Maybe I'll increase the line thickness a little bit. Okay. So for fractions, let's do a little quick review on how fractions work. Okay. So to add two fractions together, what has to be true before you can add or subtract fractions?
Anyone.
The denominators have to be equal.
Absolutely. Perfect. So what's one quick way to do that if they have different denominators?
Multiplication.
Multiply.
To multiply the denominators.
Gotcha. Right. So you can multiply a number, you can multiply any number by 1, and that keeps the number the same, even if it changes what it looks like. So if we take the first number here, multiply that by the denominator of the second one, take this one, multiply it by the denominator of the first one, so we get so what we get is, AD over BD plus BC over BD. And so our total answer from that is, A times D plus B times C over BD. Okay, so that works with addition and subtraction. Multiplication is a little different. If you have A over B, excuse me, where's my eraser? There it is. Times C over D. Okay. If you want to multiply two fractions together, how does that work?
Is that the one where you cross multiply?
Not quite. It's easy. It's simpler than that.
Don't you just multiply across?
Yes. Okay. So for multiplication, you just go straight across. So, yeah, those are, that's most of what you do when you are dealing with fractions. Now, someone said cross multiplying. So when you have division, that's when that whole cross multiplying thing comes in. This is, let's see. Yeah. This equals, so A, B over C, D. And this basically goes into D over BC. I believe it's something like that.
That's nice.
Yeah.
Okay.
All the things get all flipped around. It's all confusing. We won't be doing any fraction division for today. I when I was in high school, I just had to put this on a note card. Right? And even in college, I was just never able to keep that in my head. And I'm just like,
At this rate, the GREs are just going to all be online anyway, so we'll be able to keep a note card.
Mm-hmm.
That would be nice.
And a calculator.
Yeah.
Yeah. When I was in high college, my note cards turned out like this. Oh, they're too bad. I won't show. Oh, well. I'll show later. I have to turn off the virtual background. But I use like a 0.3 lead mechanical pencil to type these little tiny things. So I could stuff as much as I could on a 3.5 inch note card. Anyways, okay. So
They remind me of Sproul.
okay. So I'm going to get rid of this bit because that's just confusing. We're not going to use it today. If you're dividing fractions, you're doing stuff that's, you know, probably too complicated of a solution anyways. All right. Addition and subtraction and multiplication, that's the realm we're in for today's workshop. Okay, so let's actually look at the question. So 1/3 of the trees that are not apple trees are cherry trees. 3/4 of the trees are orchards or fruit trees. There's a lot of words here. We need to break this down. So first of all, what is the question even asking us to find? So any volunteers? What is the question asking us to do?
We need to figure out how many are plum out of the total number of trees.
Great. Yes.
No, we have a smart one in the group.
The actual answer is going to be, is actually, or the actual question is, how many plum trees? That's what the question's actually asking us to do, is to figure out that. So we just need to figure out how to use the rest of this information to get to that answer. So, okay, what other things do we know right off the bat? So we see
20% are apple trees.
what?
20% of the trees are apple trees.
20% of the trees are apple trees. Okay, how do you come to that?
That's the big white letters at the top of
That's
the
the
problem.
first thing.
Ah, okay. Fantastic. They give it to us. Okay. Okay. So there's a couple different ways to write 20%, right? So, you know, 20 over 100, right?
Yes.
Let's say the number of trees in the orchard is T. Also, is everyone okay with being able to read my writing?
Yes.
Okay, I'm just using Microsoft Paint here because it was easy. It's a little pixely, but I think it'll work out just fine. Anyway, so yeah. So everyone okay with this for 20%? And does everyone understand why that means 20%?
Yes.
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 Okay, cool. So 20% of the trees are apples. Let's take a look. Okay, so apples equals 20% of T. 1/3 of the trees that are not apple trees are cherry trees, and 3/4 of the trees in the orchard are fruit trees. So when Evelyn and I were looking at this question yesterday, that bit kind of threw us off for a second. 3/4 of the trees in the orchard are fruit trees. So at first we were just assuming that all the trees in the orchard were fruit trees, but that's not actually the case. So we have to keep that into account. So let's say fruit trees equals some percentage of trees in the orchard. who any volunteers as to what that percentage is?
I already did that problem yesterday, so that's why I'm not answering you guys.
But it's 3/4, right?
Right. So that would be
75%?
right. 75%, 3/4.
So remember that he said because of our answers being fractions, we need to keep our numbers fractions in order to get to the correct answer at the end.
Yeah, are they just trying to throw us by giving us a percent at the beginning? They're like, let's start off with a percent and like.
Yep.
They're trying to see, can you convert between percentages, decimals?
And trust me, I thought it was all go-getter, and I was thinking I was going to get the answer, but I forgot the multiplication pattern. Threw me off entirely.
So 75%, 3/4. This also equals, 75 over 100. While you're doing these, you can kind of, all these things are equivalent. Since we've already got something in the hundreds, I'll just 3/4. We can swap this with any of these as we need it. Okay. 1/3 of the trees that are not apple trees are cherry trees. Okay. And then the only type of fruit trees in the orchard are apple, cherry, and plum. What fraction of the trees in the orchard are plum? Okay, so 1/3 of the trees that are not apple trees are cherry trees. So we have, let's see.
I'm like,
So-
yes.
We need to find, hold on.
Don't get nervous. It's fine. I promise you they won't judge you.
We're trying to find plums. So we need to set up an equation for this, and that'll tell us what else we need to find. So plums is going to be equal to the number of trees in the orchard that are fruit trees, but not apple or cherry. By the way, do you have the note card of where we wrote this out yesterday? I think it's in your notebook.
Might have thrown it away out of anger. I don't know. Give me a second.
Okay. Anyways. So
You might want to move on with your own. We just started doing the. Okay, here it
Is
is.
it a page? Yeah. Do you mind just handing me that page? Great.
Did you forget how to solve the problem?
No. Here we go. Thank you.
You're welcome.
This is making me hungry, though.
I know. I'm like,
Good.
Yeah, I need some
Just
home
do
run
the
pies in the gas
equation.
station.
Yeah.
Just go from like how we solved it yesterday. Go a little bit faster though. Like for me, I don't know. I don't know how you guys feel about it, but I feel like I need to see it more laid out that way.
That's only because you did this problem yesterday. No one else has.
Yeah, I think the pace is good. I haven't thought about math in 13 years, so it's fine.
All right, Lee. Just because you say so.
Thanks.
I'm gonna walk away. I'm gonna go and make a coffee, you guys.
Hey,
Yeah.
coffee.
I appreciate the pace because I was able to go downstairs and refill my coffee. So
No wonder he disappeared for a second.
Okay, carry on, Scotty. Thank
Okay.
you. Sorry.
Okay. All right. So, and I'll use lowercase. What you doing?
I'm gonna make you a tea.
Oh, I'm just use a different cup. I'm okay. I'm drinking this one, but thank you. Okay. Okay. So, is everyone okay with this sort of notation here, and kind of what I'm doing here?
Yes.
So the number of fruit trees, the number of plum trees is equal to the fruit trees minus the apples and the cherries.
Mhm.
So we need to figure out what A is, what F is, and what C is. So in other words, they gave us A, and they gave us F, and so we need to figure out C on our own. So a third of the trees in the orchard are fruit trees. A third of the trees that are not apple trees are cherry trees. Okay, it doesn't say a third of the fruit trees that are not apple trees or cherry trees. It just says a third of the trees. So knowing that, some percentage of the trees is equal to cherry trees. Any thoughts?
So if we know that 20 out of 100, if we're assuming it's 100 for a moment, are apple. The ones that are not apple is the remaining 80.
Mm-hmm.
So the trees that are not apple trees is 80 out of 100, and then a third of those are cherry. So it's a third of 80, which is not a round number, but
Okay. Let me see. Right.
does that
Let's
make
see.
sense?
Yeah. So let's see. So a third of the trees. Can you say that one more time?
So the trees that are not apple
Okay.
in the whole orchard is 80 out of 100. So
Okay.
80%. And then
Right,
a
because we had
third
20
of
are apple, right?
right. Ooh, upgraded.
Oh
Just
wait,
like
is this
meeting.
like, is our meeting time like limited?
If you use free Zoom, it's limited, and
Oh.
but I mean we have it like the paid version through school. I don't know.
Hmm. Okay. Well, we'll see if it cuts me off in a few minutes.
No, we should. I've hosted like long through our version of Zoom. It's like the paid version, so we should be fine. Anyway, so it's 80 trees, and then a third of that 80 number is cherry.
Mm-hmm. Okay.
So that's, I don't know how to notate that, but
right. So let's see. Right. So not apple trees equals 80%. So a third of those are cherry trees. So 80. So that's so 80% is 80 over 100, or 4/5, right? If we simplify it, because 20 goes into 80 and 100. So C is going to be equal to 4/5 of the trees times a third, right? And then we can do the straight multiplication here, right? So that gets us 4 times 1 over 5 times 3. So that gets us 4/15 t. Okay. All right. Everyone with us so far?
Yes.
Okay, we're surviving fractions so far. Let's see how we can get to the end here. So let's take our plum equation here again. So plums, it's going to be equal to the number of fruit trees minus the apples and the cherries. Okay, so we've got 3/4 of the trees. I'll just remove the t for now. 3/4 minus number of apples is 20 over 100, or 1/5. Is everyone see how I was able to go from those two?
Yeah.
Just simplified, 20 goes into 20 once, 20 goes into 100 5 times. Plus cherries, which is 4/15. Okay, so the first thing we need to do is we need to should be doing this right. Yep. Okay. So we need to add these two together because what's our order of operations? It's parentheses is the first thing we do, right? Everyone familiar with PEMDAS?
Yes.
Great. Okay. Parentheses, exponents, multiplication, division, addition, subtraction. So we're going to do the parentheses first. So we can simplify, or we can get a common denominator here by taking this and multiplying it by 3/3. So we can get, I'll just kind of simplify it right here, right underneath it. So we get 3/15 plus 4/15. So that gets us to 7/15, right? So we have 3/4 minus 7/15. So now we need to come up with a common denominator for these. Anyone want to try and do that on their own? See what we come up with?
I mean, I guess the easiest way is to multiply them. 4 times 15.
Okay. And what do you come up with?
But 60.
All right. So yeah. And in this case, 60 is the lowest common denominator that we can get. So if we do, so let's do both sides. So right, so we have 15 times 3 and 4 over here. And we have 4 times 7 over 4 times 15, right?
Mm-hmm.
That gets us 60 in the denominator on both sides. So 4 times 7, what is that, 21?
8.
Or 28?
8.
28, cool. Never learned my times tables. And then 4. Oh, whoops! I'm at the wrong side. 28. And on this side we have 3 times 15.
45.
45.
Yes.
Okay. All right. So 45 over 60 minus 28 over 60. And here is the part where on the GRE, I believe they allow you to use a little pocket calculator. This is the part where I would say use your pocket calculator because it's subtraction, and subtraction's hard. So we get boop, minus 28, 17. So our answer is 17 over 60. And if we take a quick look at our answers here, that happens to be one of the answers on our list. So that's pretty good confirmation that we've done a good job here.
So I guess it never, like I was sort of thinking just initially reading through the problem that we would first have to figure out how many trees total, but I guess that never mattered.
Thank you.
Like we never had to
it does
figure
not
out.
actually matter. This whole question is about ratios. There's no need to find how many actual trees there are. Just the percentages.
Gotcha.
And a lot of these questions are going to be like that, where you maybe don't have any numbers. You just have a description of what the scene is like, and you have to figure out what those, those ratios are, those percentages are, et cetera. But yeah, so before we move on, does anyone have any questions about this problem? About any of the things that we did in order to get to the answer?
So can you explain how, like when looking at a question like that, even if it's different wordings, what are the keywords to identify what kind of problem this is?
Okay, so as you're reading these questions, because again, they're not going to give you a lot of time to do the problem, you have to be very careful about reading the question in the first place. So as we're going through this question, there's a lot of information. It's very dense and very complicated on purpose. And the first thing that I asked us when we started, after we read through this problem, is what is even the question? I mean, as you were probably reading it, you were probably saying, okay, I know a third of the trees are apple trees. There's this ratio, or 20% of the trees are apple trees. So many of these are cherry trees. And that's all information that you need. But you can get very lost into figuring out what is the question you're going to ask me to find. And that's just a skill that you kind of have to pick up by doing these questions. If you go into the GRE cold without having studying, you're probably just going to be lost. You're going to spend a lot of time wasted just rereading the questions. One of the skills that I'm trying to help you guys with by doing this GRE prep is to help you be able to read the questions. That's actually very difficult. As you can see from this question. How many of you honestly knew what the question was asking you to do after your first time reading the question text?
Not me, honestly. I thought
I didn't either. I had to read it a second time and figure it
Yeah.
out.
I really was like stuck on like, okay, I got to figure out how many trees there are total, and obviously that was not important at all. So.
Oh my gosh. I was stuck in doing the cross multiplication really.
I was at 20%. I was like, it has to be a percentage, but then none of the options were percentages. So it's like, what? Why is that even there?
Mhm.
Okay.
Yeah, and you bring up a really good point, because all the answers here are fractions. So that tells you whatever you're doing, you're going to need to take your get an answer that's in the form of a fraction. If you have your pocket calculator, I mean, you might feel more comfortable, typing in these values and trying to get a decimal answer. And that's going to be a little tricky, because it's going to be hard to convert a decimal answer back, an approximate decimal answer back into a full fraction, which is infinite precision.
Do they you said they let you bring a simple calculator, like not a scientific calculator, so it's
Right.
like literally like plus minus subtract, like
Yeah. I believe when I did it, they allowed you to take in, like, if it can be solar powered, it's probably okay.
well,
You're not going to be allowed to take in
okay.
your TI-90s and things.
Right.
No graphing. I literally got a pocket calculator at the dollar store. That would probably be about the level they want you to take in. Maybe like through high school, I had a TI-32, I think, and that thing was great. Solar powered, but it had functions for square root and squaring and anything else you could want.
When I looked it up, it said that they provide the calculator.
Oh, that's fantastic. All right, great. If you want one for your just for working through these problems, though, the Windows and Mac calculator apps on your computer, they have all the features that you'll need for doing these problems. If you want more, stronger hardware or stronger calculating power, there's also Wolfram Alpha online, where you can type out full mathematical expressions, and that's another free resource. It'll even do graphing for you, and it's a lot easier to use than a graphing calculator.
Thanks.
All right.
All right. We
I'm gonna go ahead
we all
and
passed the GRE.
I'm going to go ahead and save all these little drawings for each problem, and I'll give them to Adelaide to email to everyone later on.
Thanks.
Let's see. Okay. Come on. Okay. So this was question 1. Boom.
I haven't done the next question, so I guess I'll be on the same page as you guys.
Okay.
So how do you guys feel? Maybe one more question?
One more question?
I don't know. How do you guys feel?
you got
That was
this.
only the first one.
I know, but should we take a day break? To day break.
This is why
Should
you
we
need
break
to
for like
practice
3
more
months
math.
and then? Yeah.
Literally.
Oh my god.
Oh, you're
Thanks for inviting us to your math party. It was fun.
You're
I'll
welcome.
see you next month.
Yeah.
Math
this on the
party
calendar.
of fun.
Why don't you the next time you create a Zoom ID, make it a math problem to figure it out, and then if we get it right, we get into the room.
Actually, so there's a
That's what I was
puzzle
gonna tell
solving.
you, Lee. Why would you say that? Why?
Don't give them ideas.
No, so there's a puzzle solving club, and their meeting location, they meet once a month, and their meeting location is secret, and you actually have to solve a puzzle to figure out where the meeting is going to be.
That's pretty amazing. Well, now their meeting location is at their house, so they're probably
Unfortunately, yes.
probably just going to be to figure out the Zoom password.
Yeah, the group is called Puzzled Pint, and they pick a different like bar or pub every month for their meeting locations. But you have to actually solve like a 20-minute long puzzle to figure out where the location even is.
That's like the nerdiest thing I've ever heard.
It's too cool for us.
Interesting.
Very exclusive.
Okay, I'm ready. Go.
Yeah. All right. Let's.
All right.
Do another one.
I'm just gonna go ahead and. Oh yeah. So this is question 2. Great. There we go. All right. More fractions. What number yields 3/7 when multiplied by 9/7? Okay, so this is going to go back to our multiplication for fractions again, right? One nice thing here is that this is a problem where if you're really lost, this is when you could brute force really quickly.
I also did this problem, you guys, so that's why I'm not saying anything.
And if we were going to brute force it, here's another little tip. If you're looking at a GRE problem and you're thinking, I think I'm just going to try running these numbers and figuring out what is best, try and start with the simpler answers. Things like 3 1/3. Don't do 18/49 first, because that's going to take a lot longer, and if it's wrong, then oh well. You've wasted like a minute trying to do that multiplication that was pretty ugly. Try and do the simpler ones first. So real quick, I'm going to go ahead and rewrite the fraction multiplication. Just goes straight across. And I'm going to show you also another little thing here too. So what's going on here between these two? It's asking you, what is this question asking us? What this question is saying is 9/7 times equals 3/7. And the question is asking, what is this thing?
So it has to be smaller. So 9/7 is getting smaller by when it's multiplied by that. So it has to be smaller than 1 because it's not increasing. So
okay. So that eliminates 7/3 and 3. So that's great. That got rid of almost half of the answers right off the bat.
Wow, Lee. I went through by just going over all of them, but I skipped the first one because it's a large number.
Yeah. I try to avoid doing math that looks complicated. That's why I'm a computer programmer. I tell the computer to do all the complicated stuff for me. I'm also lazy. So, anyone have any luck?
I found it was 1/3.
Okay. And has anyone else tried that?
I mean, it makes sense, like logically, because 3 is a third of 9. But you know, I'd like to see how the math checks out.
Okay. So you are correct. It is 1/3, and I'll show you here. So
I just used the calculator.
How did you do that on the calculator?
I divided 3 divided by 7 to get the decimal,
Mhm.
and then I just
Oh.
multiplied to see what the answer would have been, and then I just multiplied the 9/7 by the fractions.
okay.
And then the
There you
first one
go.
I did was 1/3, and that was it.
Okay.
Right.
That's great. That means you're trying to brute force it, but the first one you picked worked. That's great. And again, I'm glad you didn't start with 1849 because that just sounds so like ugly. That's why I said skip that one. Try a simpler one first. And I'll show you the math for doing the fraction way here. But yeah, there's nothing wrong with using a calculator for that. If that's, the first thing that snaps to your mind and thinking, I can do this quick, go for it. But I'll show you the fraction way here. So, and Lee mentioned that logically it makes sense because 3 is 1/3 of 9. That's basically logically what's going on here. So we have, at the top, we have 9 times 1, and at the bottom, we have 7 times 3. So keep in mind that everything on the top is multiplied together. Everything on the bottom is multiplied together. You can treat these as individual elements that you can divide out. I could rewrite this as 1/7 times 9/3, like this. Because it's all multiplied together, the order doesn't really matter. So either way, if we're doing this, 9/7 times 3, you can cross those out. 3 goes into 3 once, 3 goes into 3 in 9 3 times, equals 3/7. Up here, I just rearranged it because I could. This is exactly the same as doing that. Just rearranging the terms. And then it's like,
So how would you get to that backwards, though, if you were going to divide 9/7?
what do you mean?
Like so like this is one way to do it, is to plug in 1/3 and get the right answer. But then, like, what if you wanted to go, what number yields 3/7 when multiplied by 9/7? So if you wanted to divide 3/7 by 9/7, what's the
I see what you're saying.
process?
So if we wanted to look at this and like treat this as an equation, right?
Yeah.
Okay, let's try that. So to move, to isolate our question, let me rewrite this. So 9/7 times x equals 3/7. That's a form that's a little bit more familiar to us from algebra, right? Okay.
Yes.
So to move, what we want to do is we want to isolate x, right? So how do we get rid of 9/7?
Subtract it.
Not subtract it because
You
it's
divide?
multiplied in here.
God, 'cause
You
it's
divide.
Right. So we have to divide it out on both sides. So yeah, we're gonna get that awful fraction division. Here we
I
go.
thought we weren't doing that.
Oh, okay. I see. I'm seeing why now. You said earlier, let's try not to do that.
It's only because I guess it would be more. Well, what I did, Lee, was I put 9/7 because I was trying to just go over them. I put 9/7 times 1/3, and then I did the multiplication, which ended up being, 9 times 1, 9, and then 3 times 7, 21, and then I simplified the 9 over the 21, and then 3/7 came out.
Yeah, you always have to reduce them as lowest as they can go with fractions.
Yeah.
That is the easy way to do it, honestly.
That's what I did. But then I liked how he placed it with the 9 times 1 and 7/3 and just canceled the numbers out because it's faster than having to do multiplication with large numbers.
No, for sure.
Yeah. Anyways, if we wanted to do this though, and this will get us the answer fast. It will get us the answer fast. Sorry, I'm hearing my own voice in my headset as a little bit of an echo. But again, you just have to keep straight in your head how fraction division works. So I set it up like this. So the number up here, the number we're dividing out like this. In my mind, when you have a fraction divided by another fraction, here's what happens. This number goes up here, and this number comes down here. What you get is A times D over B times C. It's tricky and confusing. But anyways, we kind of come back up to here. That's what we wound up doing here. The 7 came up, the 7 came down. So the 7s cancel each other out. So we have 3/9, and that simplifies to
1/3. Yeah.
1/3. So yes, you can totally do it this way.
So if the denominator is the same, then it's kind of easy.
Mm-hmm. A lot of these GRE questions, that's another thing, is that if you're on the right track for the answer, the math will generally work out into a way that's kind of elegant and nice and neat and tidy. If you're doing things where the math just starts getting really ugly and nightmarish, you might want to review whether or not you're on the right track or not. You might want to just double check that you're doing things the right way. Like with this actually works out pretty well. Even though it's doing fraction division, the math works out really nicely with all of the ugly numbers kind of canceling each other out. Okay, does anyone have any other questions about this problem?
No.
Okay, cool. I'm gonna make a new drawing. Save this as 3. How's everyone doing for brain drain so far?
What?
How's everyone doing for brain drain? Does anyone need like a quick like 60-second breather? Or...
No.
I thought you said brain train, and I was like, is that something I should be reading about? All aboard the brain. All aboard at the brain train.
All right. All right, we're going to move on then. Question 3. Okay. This one had me a little confused for a while on the wording. A photographer purchases 30 rolls of black and white film and 25 rolls of color film. If the cost of each roll of color film is twice the cost of each roll of black and white film, what percent of the total cost of film is the price of a roll of color film?
My God.
Okay.
Right.
One of those, yeah.
Yeah, it's another one of those, oh God, so many words, and they're all really confusing words, and what is the question even asking me to find, right? So let's just try and translate that first. What is the question?
It wants to know
How much the color film, what percentage of the color film is from the total price?
Right. It's trying to say, what's the cost of a single roll of color film as a percentage of the total order cost?
Oh,
So it's the same as like the fruit trees. Like the total cost doesn't matter. Basically, like that's like too much information. We want to know out of the total cost, which isn't important. How much is
We don't care how much money the person spent on film. We only care about treating the total order cost as 100% and finding what percent a single roll of color film is. Okay, so what is the cost of a single roll of color film as a percentage of the total order cost? Everyone okay with my cursive? Okay, cool. All right, so there's the actual question. So let's figure out what information they give us. So what is the order? How much stuff is in the order?
I wrote down just first black and white roll 30 equals to like 30, and then color film equals to 25.
Okay.
R, like I would put, so black and white roll equals 30R, and then color film 25R. I don't know if that's even a way to start it. And then each roll equals to 2 times, and then I placed cost of roll black and white.
Okay. That's pretty good. I'm going to go a little different than what you said, but most of what you said was right. Okay. Because So you were saying 30R and 25R. That's treating the two types of film as the
The
same.
same? Okay.
And we know that they, well, we are assuming, oh no, it tells us. It tells us that they have a different cost.
Mhm.
So we have 30 black and white, right? And we have 25 color. Let's see. I'm going to use the total cost. Let's see. All right. So our total order here, then, we have 30 black and white rolls and 25 color rolls. So first what we want to do is, because we're trying to figure out a percentage of the total cost of the order, we need to figure out what the total cost is. And again, we never need to actually do real numbers here. We're just trying to get some sort of an equation going. So we also know one more thing. The cost of each roll of color film is twice the cost of each roll of black and white film. So I'm going to use the letter M as in money. No, you know what? Why not? I'll just use a dollar symbol. The money cost of color is equal to how much?
2 times.
Right. We don't have an actual number. All we know is it's double the money cost of the black and white, right?
Mhm.
So I'm using a subscript here to differentiate the two. Is everyone okay with how I'm doing this? Okay.
Yes.
Yes.
All right. I come from the computer science world where every single equation we write is just variables everywhere. There's no numbers anywhere. So one thing to help you with your math is come up with good variable names. For me, this $C makes a lot of sense. $B makes a lot of sense. Does that confuse anyone?
No.
Okay. Coming up with good variables will help you in your math as well. Don't listen to algebra people who like put X and Y and Q and R and phi and zeta and Ophelia and alpha and beta and gamma everywhere. It just makes things ugly and confusing.
That's confusing.
Okay, so we know this. The cost of color is equal to 2 times the cost of black and white. So the total cost, what's our total cost? It's going to be the cost of all the film the person ordered, right?
Mhm.
It's going to be equals to 30B plus 25C.
Okay.
I think that's this, isn't it?
Well, 30 times the cost of B, right?
Oh, yeah.
Plus 25 times the cost of color, right? So yes, basically exactly what you said. All right. So if we break this down, let's get this down to one variable now. So if we want to get rid of color, we can swap this in for this, right? So 30 plus 25 times 2 times the cost of black.
Is this where simplification happens, or like distributing happens, or
What's that?
nothing? Never mind. Continue. Sorry.
Okay. So what I've done is I've just gotten rid of one of the two variables and replaced it with the same variable. And everyone saw how I did that. Substitution, right? Okay. So what comes next? We're going to add these together. 30 times the cost of black plus 50 times the cost of black. Whoop. That gets us to 80 times the cost of black. All right. So now we want to figure out what is the percentage, right? For roller coaster, like what does this tell us? This tells us what the total order cost. The total order cost was basically equivalent to 80 rolls of black film. Everyone see how we got that?
Yes.
The total cost equals that. So if we want to figure out the percentage cost, because that's our question, right? What's the cost of a single roll of color film as a percentage?
We're looking for color, so we have black, the cost of black now.
We don't actually know what the cost of black is. We just know what the cost of the total order was, right?
Right.
Well, I mean, we know what black is. We know black is 1 unit of this. It's 1.
Yeah.
1/80th of that, right?
Right.
So, and the cost of color is double that, right? So it would be what? The cost of a single color is going to be equal to and as you're seeing was right. The cost of black is going to be 1/80th of this, right? 1 over the total is going to give you your black, right?
Yeah.
And if color costs twice as much, then what's our color cost?
2 over 80?
Yes. Okay.
I like your enthusiasm. Thank you.
Responded with alacrity.
He did respond with alacrity. I like that.
Yeah.
Good.
Now-
Thank you.
Now, see, since I was applying to engineering school, I didn't have. No one cared what my written answers were for the GRE. They're like, just focus on the math. Just study your ass off on math. No one cares what your verbal score is. But yes, I like that you guys have a very, very colorful vocabulary. Okay, 2 over 80. What's this boil down to? It's 2 divide into 80 evenly?
1 over 40?
Yep. 1 over 40. All right. And that looks like absolutely none of our answers, right?
Not yet.
Okay. All right. Time to pull out the pocket calculator again, right? What do you guys get?
Hold on. 2.5%.
All right. 1 out of 40. Right. Okay. So when you're dealing with the percentage, 100% is 1, right?
Mm-hmm.
For a decimal. So that's, where we're going. The decimal point for a percentage is right here. So it's 2.5%. So yes, fantastic.
So what's the answer on the
2.5%.
So 2.5. Oh, wait. How did you get to 2.5? Why did you move the decimal? That's
Because you multiply what you get by 100. and then it gives you the 2.5.
Right. So
Why?
when you're dealing
Like,
with
why is that
percentages-
rule?
Because it's
Ah.
you need a percentage.
I hate those things. Okay.
This is why right here. So 100%, when you're dealing with decimal, is 1. How many of you guys have taken probabilities and statistics?
I have, but apparently I
Me.
forgot all about it.
Yeah, 13 years ago, and I slept through it.
Okay. Excuse me. A ton of what I do in video game programming actually has to deal with probabilities.
Oh, really?
Yeah, lots of it. Okay, so yeah, I'm dealing with this stuff all the time. But yeah, great job there, guys. Any other questions about this problem?
So when you were first converting the cost of color to the cost of black and white, did you choose to do that even though the answer we're looking for is going to be the cost of the other one? Did you choose to do that because it's the smaller number?
Oh, you mean for right here where I said the cost of
No,
black?
a little further. Like when you were first substituting this cost of C equals 2 cost of B, and you substituted the cost of C there.
You could totally do it the other way.
You could do it the other way, but then you'd have to divide. But like
Yeah.
I'm saying, did you choose that one because you'd end up multiplying instead of dividing, which is a little easier, and then convert later? Or because
yes,
ultimately
because,
we're looking
yes,
for the
because
cost
I am
of color.
Yeah, I am lazy, and I try and go for what's going to be easier. And telling me one way does multiplication and the other way does division.
Right. Multiplication. Okay.
Yeah, we can totally do this. The cost, going from here to here, we can get the cost of black by saying, all right, cost of color divided by 2 is equal to the cost of black, right? And then in here, it's just,
So you'd end up with 15 plus 25, which is 40, which is the equation later, but it's just way more complicated. Yeah. Okay.
Yep. Right, so equals 15 cost of C plus 25 cost of C equals 40. So the total equals 40 rolls of color. And yeah, so one of those, is 1/40. So yeah, you can totally do it this way too. And it'll probably this may actually get you the answer faster because you don't have to do the 1/80.
Yeah.
Just either way, whichever way you can get rid of a variable quicker, go for it.
When you only have a minute
because
per question,
whenever
I
you're
guess
dealing with
you just pick one and roll with it.
Right. When you're dealing with multivariable equations like this, the answer is always get rid of one of those variables. Substitute it for some sort of equivalence you have with the other variable. Yeah, it doesn't matter which one. Whichever one you can get to go away faster, go for it. Okay, how's everyone holding out? Everyone feeling okay for another question?
Sure. Yeah, I think we'll because then I gotta go tutor.
Okay. Let's go ahead and go to the next one. Oh, and I'm gonna make a new. There it is. What's that?
Pretty rough.
Okay. If C plus A equals 20 and B minus C equals 8, then A plus B equals what? Okay, so this is nice in that the question is, at least the question is easy to determine, right? The question is A plus B equals what, right?
Mhm.
So who thinks they know how to solve this one? We were
I
just,
think
yeah, so we were just talking a little bit about the idea of variable substitution, right?
So we want to isolate A and B
Mm-hmm.
from the other equations.
Mm-hmm. Right. So let's write out the things that we know first of all. C plus A equals 20, and B minus C equals 8. So these are two equations that we can do some substitutions on to free up some of the variables, right? So we would write C plus A equals 20. So if we wanted to find the value of these individual variables, what would we do? If we wanted to say one of these variables on one side of the equation equals everything else on the other side, what do we do?
How when you would subtract C?
Okay. So we can get the value of A by subtracting C. So if we subtract C from both sides, we get A equals 20 minus C, right?
Mm-hmm.
Mm-hmm.
We can also get the value of another variable here too, right? We can, if we subtract A instead of C, we can get the value of C if we wanted to.
Mm-hmm.
Mm.
So that's just, you know, so we have those if we need them. We can do the same thing with the other equation, right? So what do we get for this one? If we wanted to isolate B, what do we get?
We're going to add C to each side.
Okay. Why are we adding C to both sides? Instead of
It's
subtracting.
negative.
Exactly. Okay. All right. And if we wanted to isolate C, we can just bring the 8 over, right? So we have a couple of equations now, right? We've got A, B, and C isolated. So if we wanted to write out A plus B, we actually have those here now, right? We've got
20 minus C plus 8 plus C equals to
Yep.
the answer.
Yeah.
20 minus C plus 8 plus C equals 28 minus C plus C. Oh, hey, look at that. The C's cancel out.
So even though it's in parentheses, because there's no multiplication, it's all addition, subtraction.
Right.
It doesn't really, you can just isolate each component. It doesn't really, you can take the parentheses away basically.
Right, and that's the commutative property, right? Addition and
If
subtraction
you
are
say so.
commutative. You can move them, you can switch them around.
I haven't heard that. property, but yes, that's good to know.
Mm.
So you can take the parentheses away, and then what you're left with is the sum
Right.
of everything.
Yeah, because if I have, 10 apples, and 10 more apples, and I add them together, I can always take them back apart, right? I can always split them back up into 2 piles of 10 apples each, right?
Yeah.
Or if I have 20 apples and C apples, I can always split them back up into a pile of 20 and a pile of C, whatever C is. In this case, as you've kind of, the overall theme that's been going on here that Lee has been kind of bringing up to us is that we never figured out what C even is, right? We don't even know what A and B are. We just know that A and B added together is 28. And that's going to, as you can see, that's just kind of how these questions are. It's a lot of, we don't really care what the actual number is for, most of the things we're dealing with. We just care about, the answer. Okay, how's everyone feeling? Good for one more, good for a 5th question, and that'll be half of the ones provided on this practice test. Everyone okay?
Yes.
Yeah.
All right, and I think Adelaide is asking about review times for later on.
Yeah.
How are you feeling? Are you okay with another question? Okay. So yeah, definitely follow up with Adelaide in the chat room about when everyone is good for more study sessions. Again, I'm pretty open right now, so I'm totally happy with and pretty open for any time you guys want to be able to make it. I'm going to go ahead and make a new question page.
We take a 4-minute bathroom break. I'll try not to
That's
take
a good
my
idea.
microphone with me.
That's a good idea. 5-minute bathroom break.
I'll take my headphones off.
All right. I'll be right back as well.
All right, thanks.
Mute and open your record on your video.
Okay.
So you see in the corner?
Mute my audio. Okay. We are recording again. And yeah, we're ready to go on to the next question. So this is question 5. The last one was 28, right?
Yes.
There we go. Okay. This is another like ratios kind of question. A certain school has 50 students assigned randomly to 5 distinct classes, and each student is assigned to only one class. If the number of students in the classes are consecutive, what is the probability that a given student is in one of the 2 larger classes? Okay, so the question is, at least this time, well spelled out for us. What is the probability that a given student is in one of the 2 largest classes?
Probabilities, no.
Yep. Someone saw that the P word there, probabilities. So again, has anyone here not taken a class about probabilities and statistics? Just probabilities, because probabilities can show up in all sorts of classes. Has anyone not dealt with probabilities before?
Yeah, it's been a long time.
Same.
Okay. Yeah. So there's a couple of keywords here. So let's kind of pick out the important bits. So a certain school has 50 students assigned randomly to 5 distinct classes. So, okay, so there's 50 students. And this is a good skill to have when you're doing the GRE, is being able to say, okay, let me get rid of all of the words that I can. Let me just reduce things down into numbers. There's 50 students. There's 5 classes. And each student is assigned to, the students are randomly assigned. And they're assigned to only one class. All right, so one student can't be in 2 classes. So that's good information to know. Now, if this was purely random assignment, what we would probably expect if the students were just randomly assigned, we'd probably expect each class to have about 10 students, right? Because that's just how, if they have the an equal likelihood of being in any particular class, we expect the sort of random distribution so that every single class has about 10 students in it. But there's kind of a gotcha in this question, a little trick to it. Does anyone see any other keywords that are kind of iffy about this?
The consecutive?
Yeah. That's the one that's kind of that's the wrench in the works here. So what does consecutive mean?
One after another.
Right.
Following.
Exactly. So particularly in numbers, consecutive means like numbers that follow one after another. So like 5, 6, 7, 8, 9. Those are consecutive numbers. So what this is saying, again, if this was just like purely random, we'd expect each classroom to have about 10 students. So if it was 10 and 10 and 10 and 10 and 10 for each class, is in like the number of students in each class. What's the probability that students in one of the 2 largest classes? Well, it'd be what? It'd be, they're all the same. So it'd be
well, there aren't 2 largest classes in that scenario, but
doesn't matter. They're all essentially the largest, right? So if it would just be, well, what's the probability they're in any 2 of them, right? It's
2 out of 5. Yeah.
Basically, right? Yeah. It'd be 2 out of 5. But, and that's because it's, there's 5 classes, they all have the same number of students. So being in one of those 2, any 2, it's just 2 out of 5. But, okay. Yeah. Yeah, and so 2 out of 5. And yeah, Adelaide mentioned, well, what's the percentage of that? Right? So if we do our...
It's 40%.
40%, right. And we can see that that's not one of our answers, right? That tells us that we are on the wrong track here. So this is, this is wrong. It's the right thought process, but it's wrong. And it's wrong because of this consecutive bit. because it says the number of students in the classes is consecutive, and again, this must be some sort of like private math school because no one would do that. It's like, oh, the number of students in all of our classes are equal to the numbers in the Fibonacci sequence. It's like, no, what are you doing? So, the question now. Adela had to mute her microphone because she's laughing in the background, and we're in the same room here. The question now is, can we make the number of students in these classes consecutive and still add up to 50? Because we know that's the total number of students, right?
Mm-hmm.
Okay, so how can we do that? So we know we need to fix these numbers, the number of students in each classroom, so that it adheres, so it still is a distribution of 50 students, but in a way that is using consecutive numbers. Anyone have an idea how we could do that?
I have an idea, but it feels like it's going to get too complicated. But maybe it's the way. But it would be like,
Try it.
like n, like 50 equal. If we had, n is the number of students per class. Like n is the smallest one. Then you have n plus 1, n plus 2, n plus 3, n plus 4. And so
Okay.
n plus 3 and n
That
plus
sounds
4
familiar.
are
Like
the
the
two.
factorial?
Let's try that. So n plus 1 plus n plus 2 plus n plus 3 plus n plus 4. So that gets us
Equals 50.
right. Okay. And then we could solve for n. That gets us 5n equals plus 1, let's see, 7, 8, 9, 10, right?
Yeah.
Equals 50. 5n equals 40. N equals 40 over 5, which equals, what, 8?
8.
Okay. And so that would get you 8, 9, 10, 11, 12. Hey, that works. I'll be completely honest with you.
Wow.
That's
not
the right way to do that, and I didn't do it that way.
Oh, okay. I'm curious to know what other way, because it's like my first initial reaction was to be like, this is how I think I should do it, but it sounds.
No, you're absolutely
I guess
right.
It wasn't complicated.
I'll show you how I did it, though. I just took 2 away from this and added them here. And I took 1 away from this and added it here. So I got 8, 9,
yeah.
10, 11, 12.
Oh, wow.
It's the same.
Yes, it's exactly the same. I really like the way you think, though. That's definitely like the right mathy way to do it.
Mathy way.
Oh, Lee.
I just,
He's
I just
mathy.
Yeah, I try to be as mathy as I can.
that's what we're here for today, right? Is to find the mathy way to do things. So yeah, both those ways totally work. I just saw a pattern matching thing that I could do.
But why would you? Where did you get them? The two would be out of the 2 larger classes. So you took the 10 minus 2, and then you just went in a consecutive order. Is that where you got your number from?
Yeah, well, I saw this as a string of 5 numbers, and so it just I just kept the middle number the same and made the other 5 consecutive with that.
Okay, I see what you're saying.
But yeah, I mean, either way, this totally works out the same way. So now we have, we actually do have two highest number classes, right?
Mm-hmm.
We have a class with 11 students and a class with 12 students. So now what do? We have to figure out what the probability is that a student winds up in this set of classes, right?
Mm-hmm.
So how do we do a probability for that?
I don't remember.
So instead of 2 out of 5, I mean 2 out of 5 is when they were all the same.
Right. It would have
So
been.
we need to take
it would have been
those
like-
two.
It would have been 20 out of 50, which equals 2 out of 5 before, right?
Right. So we need to take those specific 2 out of the total 5,
Okay.
which
So
is
that comes up to like 11 plus 12 out of 50, right?
Yeah.
So it's like it says 23.
Yeah.
Out of 50. And what's that turn out to?
46.
Say that again, please.
46.
Great. Okay. 4, 6. Yeah. Or 46%.
Mm-hmm.
Okay. All right. So that was kind of a confusing question. Mostly because this is more of a logics, like a logic question, mathematical logic, and probability question. The math here is actually not that difficult. It's mostly about, first of all, do you know what probabilities are and how to find them? Does everyone see how we went from these numbers, the 8, 9, 10, 11, 12, to a probability? Like why we said 11 plus 12 divided by 50.
Mm-hmm.
Is anyone unclear about how we did that? Or why
I
we
get
did
that, but couldn't you just rephrase all of, most of these questions we've been doing as calling them probabilities? It's just like seems like it's a different name for the same thing. We're talking about how many fruit trees are, plum. Isn't it just saying the probability of?
Not
I
exactly.
guess-
That was a
No,
ratio.
because
That's a
the
concrete
trees,
number.
the trees is more concrete, and the ones here are in between kind of figures. You don't really
Well, okay.
know a solid.
But I'm saying you
with
could
the tree
rephrase-
question. With the tree
like-
question, that was like a ratio.
But let's say like you could rephrase that. It's just a matter of phrasing. Like if I said, if I walked up blind to a tree in this orchard, what's the probability I eat a cherry? It's
Okay.
the same. It's you're solving for the same information in some ways.
I
but
could see how
it's just a phrasing of the question.
okay, I could see how you would say that, and in a way, I guess you could do that. The keywords, though, they definitely have like connotations and associated with them. With probabilities, you're always going to it's pretty explicit that you're going to be saying like, okay, well, to find the probability of this, it's like it's this thing divided by the total, right? Or the total possible outcomes divided by the likelihood of the outcome, or the number of those outcomes divided by the total number of outcomes. And whereas in the tree question, it's you're trying to like separate out which ones of these trees are fruit trees first of all, and then how many of those, what's the likelihood of a fruit of that tree being this kind of fruit. So there are similarities certainly, but a lot of the keywords change based on the context.
Yeah. Cool.
Awesome. Okay. How does everyone feel about moving on to the next question?
Sorry, guys, I gotta go, but you guys can continue and I'll just go back to recording. If that's okay.
Okay. Yeah, and I've been recording this session, so I'll definitely try and make, like, maybe I'll throw it on YouTube or something later, so you guys can watch it again. So would people like to keep on going, or pause, or what should we do?
I say let's call it a day.
I think so too.
Okay.
Yeah, I only found out about this 10 minutes before, so
That's what
I was
happens
not
when you
prepared.
don't look at my IG story.
When I don't watch your stories.
So
Well,
next
thank
time,
you.
stay tuned.
I guess. Well, thank you so much for
Thank you.
inviting me and sharing your
worries.
knowledge. So,
Tomorrow, 10:15. So
Yeah.
Hey, no worries. Again, this is the time to take your time through these questions, because when you take the GRE, the hope is that this will all be in your head and you'll be able to just go and be able to do it. This is the time where it's like, okay, let's take our time. Let's really think through these problems, how to do them. Let's freshen our mind up how fractions work, how probabilities work, how ratios work, how trigonometry works, which the next question was a trigonometry question.
yeah, that's what I was going to ask.
Okay.
It seemed
No.
like it was all algebra based and with obviously probabilities and different, but basically algebra solving for n. But how much knowledge do you need to go into it, going about shapes and those like set ratios?
There is another bit about the GRE that not everyone knows, but the test actually does change its difficulty based on how well you do. So it used to be, when I took the test would change its difficulty on every single question. So if you answered a question correctly, the next question would be harder. And then if you answered that one correctly, the next question would be harder after that. And so it would just keep on going through, the whole like world of math at you until it could peg you for a specific skill, or to a specific like a skill range. Now I think there's 2 sections of math instead, and how well you do on the first section changes the difficulty of the second section. So the yes, you will need trig knowledge. I don't know if you'll need calc knowledge or not. I don't remember. It's been too long
I think
since I
I
took
saw
the test.
some what is it? The shape ones. Geometry.
Right. The next question is does have to deal with triangle relations. So when we come back, we'll be able to go through that one, and I'll we'll get to if you don't remember, take a look back through the Pythagorean theorem, because
my favorite.
that's the fun one. Remember? Who remembers what the Pythagorean theorem is?
I remember.
A
a
squared
little.
plus b squared.
You could go C
Or
squared.
no, that's
That's the one. Okay.
Yeah.
that's the one.
Just to
How to-
preview. Spoiler.
Oh my god. Okay, I think it's enough math, you guys.
Okay, guys.
Lucky you guys got to disconnect.
Oh my god.
All right. We'll call it a day there.
Okay.
All right, bye guys. Take care.
Bye.
Thank you,
Thank
Scotty.
you.
so much.
Everyone.
Thank
All
you.
right, bye.
Bye. Bye.